All right, we're back. Welcome back to the Pacific Transformer podcast. I'm Marty. I've got Justin back here with us today.
What's going on, Marty?
Oh, excited to do another one of these.
Absolutely. Can't wait. Let's dive
Actually,
in.
we've gone over a couple of the industries, and so we're in the industry series right now, just working our way down through the near dozen industries that Pactran has served over the years. And this one's another really interesting one, honestly. Medical. If there's anything I know about medical, there's a lot of red tape. So it'll be interesting to get your take on it and kind of get into the history, how Patran got into it, some of the stuff that you've gone through. If you look just based on the site alone, some of the innovation and some of the parts, or I guess products that you guys have been involved in have been really impressive, right? You've had the opportunity to be involved with some pretty amazing things.
Yeah, it's fun. It's quite often for a lot of the projects we work on, we're simply given, a spec sheet, and it says, "Hey, Justin, we need 120 volts in, 240 out at 2 kVA." That's it, right? The fun part of our job is when we go out to either the customer's location, poke around their shop, start talking to their engineers and upper management, and get a better sense of actually what the system is using, our transformers or inductors or chokes, and looking at the entire picture, right? And so when it comes to the medical stuff, because of the importance that the magnetics plays in the overall system, that's one of the industries where we're very few times are we just given the spec sheet and it says, just give me my transformer. Usually we do get to be involved in part of that conversation in understanding more or less what they're working on. And so we've been lucky through that process to really start to see a lot of the new and interesting things that the medical field is working on.
Well, definitely want to get into some of the newer stuff, but let's wind back the clock. Well, let's just go high level real quick. Ventilators, defibs, cochlear implants, dental chairs, imaging equipment, surgical robots, lab diagnostics. I mean, you guys have been in a lot of medical products over the years.
Yeah, no, absolutely. And we've had a good opportunity to work with some of the best and the brightest in the industry, whether it's Johnson and Johnson, Medtronic, Kaiser, Harvard Bioscience, just all the big players in the game have been able to work with them. And through there, because they attract a lot of top talent, they're the ones who are really pushing the envelope on that stuff. And so whether it be new products or just legacy products where they really need something that's high quality, that is, indestructible, just repeatable. It's never going to vary too much. Really, really low tolerances as far as the min and max. I mean, it's really just has to be the most quality. So catering to those types of customers, it's not easy, but at the same time, it really puts our engineering staff to test, and they come out with shining colors.
Well, let's wind back the clock a little bit. Do you remember or have any good stories about some of the very first medical devices and or equipment or companies that Pacific Transformer had worked with going back in the long yeah.
I think one of the more interesting early projects we worked on is with Medtronic. And I think we're lucky, being based in Southern California. We have a lot of medical device companies around here. And so working with the guys over at Medtronics, we developed for them, they were coming up with a surgical knife.
Okay.
And it's not any old common surgical knife, nothing with a real sharp edge. And now a lot of days you kind of hear about these laser surgical knives. It wasn't that either. It was, get this, a piece of metal still.
Okay.
But it was completely dull. You can cut your hand. You couldn't cut your hand with it. I mean, you could just lay it up against your skin and it wouldn't cut anything. But what it was is it was connected to a power source and incredibly high voltage. And
Okay.
what it did was essentially when it touched the cells of a human body, it essentially separates the cell walls through that high voltage. Okay, and so the benefit of doing so is a couple things. One of them is when you split the cell walls open and you're able to do the surgery, and then when you're going back and reestablishing that connection, it's a perfect match, a perfect match with those cell walls. And so it's very, very little scarring. And so it was a really revolutionary thing at the time. And not only was it minimally scarring, but it also allowed, as opposed to with a normal surgical knife, you have to usually do kind of straight cuts.
Yeah.
It's not easy to make a turn. Whereas with this one, you can do all sorts of waves and interesting, kind of like cuts around places and unique spots. And so um, that one was really interesting. It definitely pushed us as far as our design capabilities because of the needs that they had for that product. But they were here for weeks as far as just working hand in hand with our head of design. And I remember the stories about they would bring like a chicken breast, right? And in order to show off the product, they just have a chicken breast, and then they would just go right along it, and they let us kind of use the tool, and you sure enough you just kind of have this little nice easy cut, and it just exploded the cells, and it was quite remarkable. And that I think was one of the first times where we were working with these OEMs in order to develop something cool on the cutting edge, no pun intended, and something that really made us proud to put our name on that product.
That is fascinating. Never knew the story.
Yeah, it was pretty fun.
Yeah, I've heard a couple of good stories, but yeah, that's a good one. Filleting chicken
That's
in the back of the of the shop is another new one. I know there's always some interesting stuff back there. That's definitely up there with
Yeah, I know. It's fun.
Okay, so let's talk about some of the challenges
Mhm.
that are really unique to medical. I know this concept of like isolation. You gotta be isolated. There's a lot of devices that are hooked up literally to like they're mission critical, hooked up to a heart, and we can't have AC power ever being able to jump the tracks, if you will. So, can you talk about some of the unique challenges in terms of developing a product and some of the things that you have to go through? And then maybe we'll jump after that a little bit towards like, well, there's got to be some heavy regulation there. And so maybe we'll jump right into that as well.
Sure. Yeah. On the electrical side of things, absolutely. There's the isolation of any sort of kind of feedback or anything going back and forth. So there's multiple techniques that we use in order to make sure that we reduce that to basically zero. The big one for a lot of the medical devices is having that ultra low leakage, specifically for the current, right? There just can't be any leakage current, and so that you really get into some sophisticated design and manufacturing processes in order to do that.
What are
Um,
some of the are
mhm.
to facilitate something like that? Is it unique materials? Is it winding techniques? Unpack that a little bit for me.
Yeah, no, great question. So, a lot of it is really in the manufacturing, right? So it's doing things like when you're wrapping the primary, just wrapping it extremely carefully and making sure you're covering the entire primary, so there's no touching to the secondary whatsoever. It's actually like further insulating the primary before even winding the secondary. So, I know I'm kind of getting into the grains here, but those are
Yeah.
the types of things that you have to do. That along with like when you're potting, oftentimes these are like board mounted transformers or inductors. And so they'll have pins coming out, but in the cup, it'll have some epoxy, right? Because it's usually high voltage as well. And so the epoxy, it can't have any air bubbles in it, right? And so it seems like something that would be the most like minute detail, but we have to take every single one of these units and do this special type of epoxy mixing in order to get out all the bubbles. And then when we insert the epoxy, it has to be pulled from the bottom of the barrel, like the bottom of the container that we're using in order to mix it. And then once it goes into the cups themselves have to go into a vacuum chamber, which then like creates vacuum pressure, pulls all the remaining air bubbles out of that epoxy. And so it's just all these little tiny nuances to that manufacturing process that you have to do in order to meet this low leakage current. And we're talking about like 10 microamperes. So like nothing, like no leakage at all. So if you don't do those things, you're going to be tripping that every time, and it's not acceptable in the medical field. So these are the types of little things that we have to do for every single one of those units.
With a lot of these products that you guys build, after it's done, I assume in these types of mission critical situations, they all have to be, every single one has to be tested that go out the door, right?
Yeah,
So
absolutely, yeah. And to that point, no, you're right, Marty. And so this is 100% testing. There's no lot testing or anything like that. Every single one that comes through the line, we do inline testing. So it's not only just like, okay, we manufacture the entire product, and then at the very end we test 100%. It's every step of the process we do inline testing. So, when we wind the coils, we'll do like a turns ratio and make sure that everything's good there. When we are doing the stacking, we'll make sure that the inductance is there, and then the potting, and then test the inductance again. And then we'll go through and do all the final assembly and stuff and test it again. And so, making sure that every step along the way, we're also doing the testing. On top of that, the type of testing is to such a higher standard for the final testing. We have to have specialized equipment. We have to set our high pot machines on absolute bare minimum in order for, if it exceeds that 10 microamps amperes to trip. Right. And so it's just setting it. Usually it'll be like at a much higher threshold. And when you do the high pod, it's fine. It works. But when you reduce that threshold all the way down to that 10 microamps, then anything that exceeds that is going to pop it right away. And then that's a default. And so we set it aside and continue on with the rest.
And maybe you do or don't know this right offhand, but how many that go through that process are rejected? I'm assuming you're going to, out of a lot, you're going to get some rejects after even going through all those testing. It still happens. It's still, you get some rejects, even though you have all this line testing. I'm assuming some do get rejected.
Yeah. And I give a ton of credit to our entire team out back because the frontline guys work with our engineering department and our design and lab techs so closely that by the time when we do first articles, prototypes, absolutely, we're failing all the time, right? I like left and right, but that's the whole point, right? So we try and catch everything up front during the first article stage and prototypes and try and understand where the failure points are. And then once we fully understand those failure points, we go back in and create either a jig or a manufacturing process that helps reduce and mitigate those risks so that when we go to full production, we don't run into that as much. Now, obviously, we still have defects, but it's what the idea is when we first release something, okay, it already went through the prototyping process, and so we've minimized the risks as much as possible. And then when we're in production, we'll still have a small amount, but that should dissipate over time because the frontline guys are getting used to doing the same things again and again and again. And when you're having that sort of high repetition, not only does your efficiency get better, but your quality shoots through the roof. So I would say, if it's first batch, first time that we're ever making it, sure, our DPPM is going to be, probably around 1,000, right? Which is, 1,000 failures per every million part,
Oh,
which is still
okay.
fairly low. But after that point, there should be close to zero.
Yeah.
And that's even in-house. Now we're catching everything, and it's zero tolerance as far as our customers. So once it leaves the back door, we should have no excuse whatsoever.
Yeah. What are some of the hoops and hurdles that you have to jump through in terms of regulation and compliance and on all that fun stuff? How do you get those certifications? What hoops do you need to jump through in order to be able to build a medical transformer or a part for a medical device?
Yeah, good question. And this is where our cross competencies have really helped us because we do a ton of stuff in defense and aerospace, and harkening back to our previous episodes on the podcast, talking about a lot of those nuances of the certification process and the necessary things that you need in order to manufacture and be in that space, such as like AS9100. That's a pretty high standard when you're working with the Department of Defense.
Yeah.
And so we already have the entire department and processes in place for those types of high-end projects. And it makes it really easy to just copy and paste for stuff like medical. So there's not a ton that is difference between, our standard, ISO, AS9100, and the things that we are putting in place for the medical stuff like the IEC 60601, and then just your standard UL and TSA listings that help out with the medical projects as well too. So a lot of it is fairly similar as far as this testing thresholds, the quality procedures, the clean rooms, and those types of things. We already have checked most of those boxes anyways, and we have the competencies in house to accommodate.
So I'm assuming you have to get those certifications ahead of time, and a third party comes and evaluates your processes and your facilities to check the box to say, hey, these guys meet all the requirements in order to get some sort of a IEC listing or whatever the case may be, right? And a lot of those, getting back to what you're saying, because I'm just regurgitating at this point, but because you've already hit the strict guidelines for defense, many of those things already cross over. So it's just a matter of almost a formality where someone comes in, reviews them again, which you've already have exceeded or hit those thresholds, and then you get their seal of approval.
Yeah, absolutely. And it's because we've already gone through not only those third party agencies who come in and do those audits once a year and or twice a year, but then we also have customers that are coming in and doing similar audits to make sure to ask those same questions and then go through and actually walk the factory floor to make sure that we aren't just writing it on a piece of paper and storing it away. We're living, the quality that we say we do. We have the processes in place and we abide by them every day, and we wholeheartedly live those out on the shop floor.
Yeah.
So because we have those customer audits and they're coming through so frequently, it is really just armed us to be able to work with pretty much any client.
Now, call me ignorant, but does in the medical field or any field for that matter, does the customer, is there a third party involved to do testing before it leaves the floor? Like they do their own independent audits in terms of like a test on this stuff or reviewing it, or is it sometimes where the client will just come in, bring some of their own equipment, and they will be going through it as well? How often does that happen, or does it happen at all?
Yeah, so we definitely see that a lot on the defense side of things,
Yeah,
where they'll hire a third party inspector to come to our shop. And
yeah,
even after we do final testing, we'll bring in a batch and they will test it themselves prior to the entire shipment that goes out. Don't have too much of that on the medical side of things.
yeah,
So it's not unheard of, but it is much less rare than it is with the defense and commercial aerospace side of things.
yeah. Let's wind back to COVID, where they had um, an influx of, or which I should say, a huge lack of ventilators. Right. I
Yeah,
remember I remember a couple posts where Tesla employees were taking they showed like the screen of like a Model 3, right? And with hooked up to like their HVAC system, and they're showing that, hey, in these types of highly unique circumstances, they scrambled their engineering team so they could start building these emergency use ventilators based on car parts.
yeah,
And I know, going back to I think some of the defense stuff, where once you sign up for defense and you're working with the government, you basically say you sign the life away and say,
yeah.
hey, in these types of situations, we have to halt everything and we have to procure parts for these types of situations. Did it come to you? Did the same thing happen back in COVID, where guys were forced to stop the line in order to build parts for medical devices that were in short?
Sure. Yeah, yeah, and it's ventilators. It kind of gets all the publicity because that was like a main thing that everybody was talking about.
Yeah,
But it was a lot of stuff, right? You're talking about power supplies, isolation transformers for medical equipment, which is just a very simple device, right? But it's absolutely imperative. Like emergency rooms can't operate without medical isolation transformers. They just are the workhorse of the ER. That as well as you look at other things. So we have a customer air quality management company, and so what they do is they do the uh, air cleansing. So they clean and sterilize the air that's coming through buildings, hospitals, schools. So companies like that out of nowhere became huge demand, and for that exact same reason, they were able to, essentially say, Pacific, you got to keep your doors open. We need this because we're getting hammered by our customers to say, hey, this needs to be our hospital needs to be retrofitted immediately.
yeah,
Our schools need to be retrofitted, our government buildings, whatever it is. Everybody was coming to them saying, hey, we need these air filter systems that are able to cleanse the air with ionized rays in order for it to get clean. And so it was one of those things where all across the spectrum, we were getting letters left and right from our customers that were the official letterhead saying, guess what, guys, you have to stay open. You have to be able to provide us because we're receiving the demand from the government that says these are necessary fields and medical
wow,
items.
wow, that's fascinating. So yeah, you were one in the necessary fields in order, and you had to keep the doors open.
Yeah. Yeah,
Wow.
no, absolutely. Didn't have much of a choice.
All right, so let's get into some of the hallmarks here. Worked on a lot of different things.
Sure.
The surgical knife was amazing examples. What are some of the other? I mean, we when we go back and talk about aerospace, we talk about the Mars rover and
Yeah.
Hubble and a lot of other things. What are some of the standouts in terms of some of the medical either breakthroughs or just the workhorses that you guys
Yeah.
have been a part of?
Yeah. I think the one that's always kind of funny is every time I'm getting my teeth cleaned, right? I'm like sitting back in the chair and you're looking at that like dental light that's just coming right down at your face. And if you like stare up at the logo there, it's basically like 80% of the dental chairs in America have like our transformer in it, and it's the one that allows it to raise up and down and lean back, and then with the
Yeah.
light coming over it. So there's all sorts of magnetics in there, and so that was one of the ones where we've just done thousands and thousands of magnetics for these dental chairs. So like talking about your workhorse, like that's it, right? You
Yeah.
know, it's like nothing fancy.
Yeah.
No, it's not sexy, right? It's a chair. But you better believe it's in 80% of every single dentist office in America. They have that dental chair there. So
That's some
um,
market share. That is some market share
it's all
of
over.
dental chairs for that company. Good for them.
It's crazy. Yeah, no, and I mean, yeah, everything we do a lot of lasers, right? You know, and so like ion lasers with our friends over at Cambridge Lasers, and then Johnson and Johnson Vision, where it's like the minimally invasive surgery on eyes and stuff like that. They use lasers as well too.
Yeah.
So really cool stuff on that front. And then with Harvard Bioscience, they have this it's like this little machine that does electrofusion and electroporation, which basically, if you're familiar with it, it's this a box and it has a cord coming out, and what it does is it basically opens the cells, so not unsimilar to the knife that I was talking about, but what it does is it blasts the cells open in order for like DNA, specific like genes, to get inside, or certain types of medicine or antibiotics or whatever they're trying to put into the cell. They blast it open, and the genes go in, and then it closes up. So working with
Wow.
companies that, yeah, do that type of thing that you didn't even think was possible. It's pretty interesting to get involved in that stuff. So yeah, that's the electrofusion stuff. A fun one we're working on right now is with a company down in San Diego, and it's called Pulse Field Ablation, or PFA. And so basically, it helps to save patients who have AFib in their hearts, right? And so usually you would have a like a pacemaker, right?
Yeah.
And so what a pacemaker does is a heart is like a electrical circuit basically,
Yeah.
and you have AFib when the circuitry hits like a short circuit or something, and it creates like a double pulse or something that is not correct as far as the way the heart should beat. And so a pacemaker just basically like resets the whole system. It shocks the heart and then resets the system, and it does some damage, so a little bit of damage to the internal organs and the
Yeah.
individual who has it, but it keeps them alive, so that's good. Um, so what this PFA does, though, it's extremely interesting. So they take again high voltage, and it's a device that they use in order to basically use extremely high like magnetic fields in order to create scar tissue on portions of the heart in which that circuit was short circuiting, like in that specific spot where it's always short circuiting. So they'll create these types of abrasions on the heart, and it's a good thing, right?
Yeah. Yeah.
But they do it without heat or without scarring, but they basically create this scar tissue with these magnetic fields and with this high voltage. And they're able to do that in a way that's very minimally invasive and extremely effective, so that they no longer need pacemakers, right? And the top portion of the heart, that's easy to get to. It's thinner walls, but the bottom portion is really like heavy muscle and really dense. And so that's where a lot of people, have serious issues is on the bottom portion of the heart. And this new type of technology, the PFA, would also allow to get to that deeper tissue. in order to create those ablations and help with that portion as well too. So really, really cool stuff, right on the cutting edge, and we really think it's going to make a difference. So it's really, really fun stuff to be a part of.
Yeah, that is fascinating.
Yeah,
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 real. Wow. I mean, that's really cool technology, and it's what a time to be alive. You can imagine all the things in the near future between with AI and all this stuff that's happening, and these breakthroughs in technology. It's going to be fascinating to see how the medical industry continues to change over the next several years. What a time! What a
yeah.
time for
No,
our kids too.
you're gonna have to be taking care of us till I'm 200 years old. You know, it's
I know. Oh God, please
we'll
no.
see.
Oh, that's fantastic. Well, Justin, this has been fun. I mean, I always am. It's fascinating to get a look behind the curtain in a particular industry and kind of understand the nuances and the work that you guys have done and what it takes to build a transformer for a particular industry. So, looking forward to the next one. The next one we have on the docket is the automotive industry, which I know you guys. There's some really good stuff there between the work that you've done in hybrid vehicles, electric cars, and electric car chargers, and RVs. There's a lot on the table there as well. So I appreciate the time as always. Like, comment, subscribe. You know what the kids say. And we try to answer any kind of questions that you guys have on there. So appreciate it. Thank you, Justin. Until next time.
See you, bud.